In this video, we'll create a simple program to display an integer to the console. That would be the Mars console down here. So before you begin, just begin in your text editor, and you need a .data section and a .text section. The period in front of the word data, the period in front of the word text indicates to the assembler that this is a directive, in other words, a command, and it knows that the .data section is reserved for declaring any variables, whereas the .text section is reserved for your instructions. I've seen them reversed so that you'll see .text first and then .data, so the order in which you have them is acceptable either way. So the first thing I want to do is declare a variable, an integer variable. So begin with the name, num1, followed by a colon. Then you need the data type, and the data type really is tied to the size of memory that you'll need to store it. Integers require 32 bits, so that would be .word. A word is 32 bits long, and then followed by the value I'm going to initialize to. So this can store either a negative or a positive. A .word can store either a positive or negative value. Now we can begin writing our code. The first thing I would like to show you is the syscall codes. So we want to just display this one integer. So if you go over to Blackboard, in the Chapter 10 folder, I have number 5 syscall functions. Click on that resource, and it will give you a chart of each of the services that syscall provides, the code required to implement that service, and then the value or the arguments required in order for this to happen. So the print integer is a code 1 that needs to be moved into register V0. The value to print needs to be moved into A0. So that's what we're going to do next. Okay, now go ahead and go back to Mars, and the first thing we'll need to do is move our value into the A0 register. In order to do that, we're going to use a load word. Remember, loads a register. The W word is for the type of data we're loading. First thing is the destination register, A0, and then the value. Okay, so the C++ equivalent to this would be register A0 set equal to the value stored in num1. The next step then would be to perform, to move the code in. So again, here we're using a load because we're loading the register V0 with the value 1. And instead of word, it's going to be immediate. Immediate because the value 1 is a constant. So load immediate destination register first, followed by the constant value. And again, the C++ equivalent of this is V0 set equal to 1. Now syscall. Next step is to end your program. And to end your program, the code is 10. So load immediate into V0 again, 10, the value 10. I know this because it is on the chart that I just took you guys over to. Then a syscall. No arguments needed because that just is referred to as a halt or end program. Okay, so once you have that, you can save your file. So you'll be required to save it first, then assemble. Remember, we're not compiling, we're assembling the instructions. A little different than C++. This is a run, and this is stepping one statement at a time if you're debugging. So you just want to run. And if you look down on the bottom window, you'll see that my integer displayed. So go back over to my code so you can take a look at the code again.